How Shor's algorithm breaks the internet. So, introduction is the internet's digital lock. Ever wonder how your credit card details stay safe online? It's all thanks to a digital lock called RSA algorithm. And but what if we find a new kind of key that could open almost every lock on the internet? Um, Today we are talking about Shor's algorithm and the quantum computers that could run it. The foundation of internet security is RSA encryption, and it's pretty much everything is uh, encrypted using RSA. So imagine how it works is like you want to send a secret message and you lock it in a box using a public key which is visible to everyone, like an open padlock that everyone can see. So usually this public key would be like a huge number, depends on the bits, and this huge number is created by multiplying like two secret prime numbers together. For example, like this is just an example, like primes 13 and 17 multiply to create the public number 221. So it can be a public key, but it's like a easy one to crack. But the public keys that are usually used for encryption on the internet are very big. And so to unlock the box, you would need the private key. So this key is derived from those original secret primes. For example, like 13 and 17 in case of 221. For a normal or classical computer, figuring out this secret primes from a huge public key number is practically impossible because that's the difficulty. That difficulty is the cornerstone for today's digital security, and for it to calculate those primes, a current day computer would take billions of years. So this is where um, quantum computers and Shor's algorithm comes into play. Like quantum computers don't play the by the same rules as classical computers. So in 1994, mathematician Peter Shor created an algorithm uh, for a quantum computer. So instead of trying to guess the factors, Shor's algorithm does something brilliant. It changes the problem. So instead of just going through all the possibilities of what the primes can be, so it turns the hard problem of factoring a number into a much easier problem called finding a repeating pattern or like a period. So these quantum computers can be used to um, find this secret repeating patterns that are not usually like hard to find with classical computers and classical computing algorithms. So a quantum computer would use principles like superposition. That's where it can be in multiple states and many states at once. So and can analyze all the possibilities simultaneously and find this hidden pattern with incredible speed. So let's go a little more into how it works. The quantum classical hybrid. Breaking encryption with Shor's algorithm is a team effort uh, between two types of computers. Because like we start by with a classical computer, uh, so where we try to find guess, and if the guess if we can't find the guess, then we move to the quantum computer part, so where the heavy lifting happens, like it receives the problem and uses a special tool called quantum Fourier transform. So think of QFT as a magic lens that reveals the hidden pattern. So quantum computer measures the pattern and outputs its period, and it takes this. So when you find the period, uh, so then you can switch back to classical computer, and um so you can give it period, and with some simple math and classical computing algorithms that can you can easily find those original secret prime factors. So like with those factors found, the lock is broken and RSA is broken. But reality check, do not panic. So is the internet broken yet? Not yet. So today's quantum computers are in the NISQ era, noisy intermediate scale quantum era. So they are prone to errors like noise and heat, vibrations, and like fluctuations in those uh, factors and parameters, and like they do not have like enough processing power, like qubits, like millions of qubits, or to break any real world encryption. They have only managed to factor tiny numbers like 15, but even though like finding a primes for 15 is not a difficult thing, but it uh, it is like a proof of concept that it can be found out using quantum computers. So we are just not there yet. Like it's not enough qubits in the quantum computers processing power. So building a machine powerful enough to threaten our security is still one of the biggest scientific challenges of our time and is likely decades away. And like in the meantime, experts are building the next generation of security called like post quantum cryptography. Like they're getting ready with all the encryption methods and security things that can be adopted when a very good quantum computer is developed and can crack all the current day encryption methods. So this will be designed to be safe from even the most powerful quantum computers. Key takeaways. So internet security relies on the difficulty of factoring huge numbers, like banking, everything from public, private data and personal data, everything is secured by RSA, most of it. And the key is like Shor's algorithm is a quantum recipe to factor those numbers quickly, and but still like the it's theoretically possible, but like we do not have a powerful enough quantum computer to accomplish it right away. So the method it cleverly finds a hidden pattern instead of guessing the factors. Um so it's between the qubits were used, and um yeah, and the threat it's a really long term threat to our current security, and we are still and like we are already working on our defenses with post quantum cryptography. Definitely the quantum age is coming, but our secrets will be ready for it.